We are going to be learning about the systems of equations, finding the number of solutions algebraically. So please make sure you have a pencil and paper ready. We have learned how to look at graphs and how to look at equations to determine how many solutions it has. But now, let's look at how to find the number of solutions algebraically. We need to find if and where. So if and where the two lines cross. So where they equal each other. To find out where they cross, we can set the equations equal to each other. For example, if I had y equals 5x minus 1 and y equals 2x plus 3, we can set the equations equal to each other. 5x minus 1 equals 2x plus 3. After setting the equations equal to one another, the goal is to try to solve for that variable. So in this case, solve for x. But as we know, not all two lines will have a solution because you can have 0 solutions, infinite, or 1. So when you are solving this type of problem, 3 things can happen. If it has one solution, when you solve for x, it will provide an exact x value. And later, you'll be able to find the y value by plugging that x value into one of the equations. But when you solve this problem, okay, let me rewrite that because I just ruined it. When I solve this problem for x, and I get a value for x equals whatever number it is, if it's an exact value, that means it has one solution. If I solve that problem and it has 0 solutions, it will provide a false statement in the end. For example, it might say, like my x's might cancel out, and it might say 4 equals 2. 4 does not equal 2. That's false. If it's false, that means it has no solution. If I solve that problem and it has an infinite amount of solutions, it will provide a true statement once we solve. For example, 3 equals 3. That is true. So that means it has an infinite amount of solutions. So again, if we're given 2 equations, and if we set them equal to each other, and we solve, if x equals a specific number, it has one solution. If it provides a false statement, it has 0 solutions. And if it provides a true statement in the end, it has an infinite amount of solutions. So let's go ahead and see how this works and how it looks. So when you are solving these types of problems, you have so many different ways of solving it. You can do it however you want, as long as it is mathematically correct. Okay, so it says this task as you solve allows you to pick which path you want to solve for the variable. Everyone will choose a different way of doing it. You might do it one way while your friend next to you might choose a different way. And you will probably get the same answer in the end if you're both doing the math correct. Remember, your goal is to try to get the variable. Okay, you're trying to figure out where these two lines cross, if they cross. But really what you're trying to do is get the variable to one side of the equation, right? To say like x equals something. And in doing so, you'll end up with one of three answers. Again, if it has one solution, you'll have an exact x. It will say x equals some number. If it has zero solutions, you'll have a false statement like 5 equals 6. That's not true. 5 does not equal 6. It can have an infinite solution, which means that there's a true statement like 8 equals 8. That is true, so that would mean an infinite amount of solutions. If you can memorize this, this is going to help you so much. Next slide. All right, so this page has 3 examples that will show you one solution, 0 solutions, or an infinite amount of solutions. Again, there are many ways to solve these types of problems. My advice is to move the variables to the left and your constants to the right. The variables are anything that have an x next to it. Your constants are just your numbers that doesn't have a variable, like an x next to it. Make a pattern for yourself, because remember, these can be solved in multiple ways. But this is my advice because this is how I solve it, and I find it to be the easiest way, for me at least. But again, you can choose whatever way you want to do it. So I have, for number 1, I have these 2 equations, y equals 3x plus 8 and y equals negative x plus 16. So I'm going to set them equal to each other. Okay. Now I'm going to try to move my variables to the left. Okay, so I'm going to do plus x plus x. These x's cancel. There you go, those x's cancel. And I have 4x plus 8 equals 16. So right now, all I did was move this x over. So I did plus x on the right and plus x on the left. All right, at this point, I have a 2-step equation. Minus 8, minus 8. I'm left with 4x equals 8. Divide by 4, divide by 4. I'm running out of room. X equals 2. This gives me an exact statement because x is exactly 2. And if it's an exact statement, that means one solution. All right, so let's look at number 2. So I have y equals 4x plus 3 and y equals 4x minus 2. I'm going to set them equal to each other. Okay, I'm going to continue whatever pattern that I made for how I want to solve it, because once you have a pattern in a routine, it will make it so much more easier for you. But again, my advice, move the variables to the left and your constants to the right. So I'm going to move my x's to the left. Look what happens when I do that. This cancels here, but this cancels here too. So I am left with just 3 equals negative 2. That is a false statement. 3 does not equal negative 2. So if it's false, it means 0 solutions. Number 3. Set them equal to each other because we're trying to figure out if they cross or not. Number 1 is showing that they cross. They're crossing at x equals 2. Number 2 is saying that they never cross. Number 3, let's see what happens. I'm going to continue my pattern, moving my variables to my left. Look, my x's cancel. I get -5 equals -5. This is true. So this means infinite solutions. If you are still completely lost, I suggest doing these 3 problems over again because this slide has an example of each. An exact solution, zero solution, or infinite. But we're also doing some more practice problems. So, what happens if there is a need to simplify? Always check if you need to simplify a side first. For example, number 4. Okay, and keep in mind what I did for this slide. I already set them equal to each other, but they really look like this. Okay, but I just set them equal to each other already for these 3 problems. All right, so on the left side of this equation, all my x's are together. All my constants are together. On the right side, my x's are separated. I need to put them together. I need to simplify. So 2x plus 4x equals 6x. Bring everything down. Always do one step at a time. As you may see right now, these look like the same exact equation. So I already know that there are going to be an infinite amount of solutions. But I need to simplify algebraically. I need to solve for it algebraically. So I'm going to move my x's to my left because that's my advice. Remember, you can solve this however you want. But when I do that, I get -3 equals -3. That is a true statement. So that means infinite solutions. See what I'm circling? I'm circling my statement, -3 equals -3. I'm circling my, what kind of statement it means. It means a true statement and the number of solutions. All right, let's look at number 5. My left is simplified, my right is not. So 1x plus 1x is 2x. Now bring everything down. Now, do you have to simplify first? No. But if you don't, you're going to be dealing with lots of work, extra steps that you do not need to do. All right, at this point, I'm going to move my x's to my left because that is my routine for solving. However you want to do it, as long as you are doing the math right, we'll get the same kind of answer in the end. So I have -2 equals -3. That is a false statement. So that means 0 solutions. And keep in mind that as you are solving it differently, my false statement that says -2 equals -3 does not need to match your false statement. For example, if you solve this and somehow you got -5 equals -1, that's also a false statement. If you did all the math right, but you ended up with different numbers at the end for the false statement or even the true statement, it doesn't mean you did it wrong. You could have possibly did it right. You just solved it a different way. The only one where it will give you an exact number is for the one solution. If you get a certain x, everybody should get that same exact x because that's exactly where it crosses those two lines. So let's look at number 6. All right. The right needs to be simplified, 6, 7, 8, 9. And at this point, it's just going to turn into a two-step equation here. 3x equals 15. Keep going. X equals 5. This is an exact statement. However you solve this, you should always get x equals 5. Everyone should get x equals 5 for when it is one solution. Everyone should get the same exact x value. Next slide. Equations. If you have trouble solving equations, they aren't going away. You need to know how to solve equations. You can also check your work visually once you simplify each side to y equals mx plus b, because that's what we're really doing, right? These are two equations that we are setting equal to each other to see if and where they have a solution. So remember my trick. It will help you. I always move my variables to the left and constants to the right when solving. But create your own pattern so that you do the same thing over and over again. Next slide. So I want you to pause this video and I want you to try these on your own. Do number 7. Okay, when I'm done talking, solve number 7. Press pause first, and then solve number 7. And then once you have an answer, check my work. Play the video again and see how I did it. And make sure we have the same kind of statement in the end. Then do the same thing for number 8 and number 9. So go ahead and press pause now. All right, so this needs simplification on this side. And I get this. All right, press pause and try number 8. All right, number 8, this is how I do it. Right now, I can already tell that it's infinite because they're the same exact equation, but I have to show my math work to prove. True, and this is infinite solutions. All right, press pause. All right, here's number 9 now. 7x minus 8 equals 7x minus 6 because 4 minus 10 is negative 6. Right now, I can already tell this is 0 solutions because they have the same slope and different y-intercepts. But continue. I'm going to put my x's to the left. I need to continue to solve this. This is a false statement. So that means 0 solutions. Next slide. So number 10, this says how many solutions does this one have? So this is just extra practice so that you can understand how to solve these problems. So go ahead and pause this and try this one. All right, welcome back. So if I put these together, this is negative 6x. If I put those ones together, that's plus 6 equals. And then if I put these together, that's 18. If I put these ones together, that means negative 18x. So then I'm going to move my variable to the left. I get 12x plus 6 equals 18, minus 6, minus 6, 12x minus, 12x equals 12 divided by 12 divided by 12, x equals 1. This is an exact solution. Sorry, this is an exact statement, so that means one solution. That means that on my graph, when these two lines are graph, somewhere on x equals 1 is where they are going to cross. Right there. Okay, but we don't know the y value yet. We'll learn that soon, but basically all that means is you plug 1 into x for one of the equations and solve for it, and that will get you the exact y value. Try number 11. Press pause. Try it yourself. All right, welcome back. 9, 10, 11, 12x. This makes -9 equals 12x. This makes -9. I can already tell that these are the same exact line, and it's going to make an infinite amount of solutions. And it's a true statement. Last one. Go ahead and try this one. Press pause now, and then come back and check. All right, for this one, it will be -3x. This will make -14 equals -3x plus 10. All right, so now I'm going to solve. Plus 3x plus 3x, cancel, cancel. -14 equals 10. This is a false statement, so it is 0 solutions. There's an airplane going by. Not sure if you can hear it. So what do you need to know from this? We're trying to find out where they cross and if they cross. Okay, and in order to do that, we need to set them equal to each other. So we can set the equations equal to each other. After setting them equal to each other, the goal is to try to solve for x, the variable. But as we know, not all two lines will have a solution because there could be 0, infinite, or the 1. 3 things can happen when you're solving it algebraically. If it has one solution, it will provide an exact x. Okay, for example, it might say x equals 4. Even though we solve these all differently, for one solution, everyone should get x equals 4 if x equals 4. If it's one solution, everyone should get x equals 4. You can plug it into x into one of the equations to find the y if you want, but we're not doing that right now. The other thing that can happen is it can have 0 solutions. It means it will provide a false statement. So in the end, when you solve, your x's will cancel, and you will end up with a false statement. For example, 4 equals 2. 4 does not equal 2. That's false. Even though you're solving it one way and get a false statement, a friend might get 5 equals -3. That's also false. If they were doing the math correct, but they were just doing it in a different way than you, and they still get a false statement, they were still doing it right. Infinite solutions. It will provide a true statement once you solve it. So 3 equals 3. Somebody else might have 5 equals 5. As long as it's a true statement in the end and they were doing their math correctly, if it's a true statement, it means infinite solutions. The end. So practice your equations. Practice these over and over again. These notes. Practice, practice, practice. All right. Wish you the best. Bye-bye.